Hello everyone, welcome to today's lesson on parallel and perpendicular. So for the past few lessons, we worked a lot with slope. And now slopes are also very useful because it can help us determine whether two lines are parallel or perpendicular, or neither. Okay, so some quick definitions here. Parallel lines are lines that never intersect. Right, so those are two lines with the exact same angle that if they go infinitely, they will never ever touch. Right, they will never intersect. Whereas perpendicular are lines that intersect, but specifically at 90 degrees. Oh, I guess I don't need to write degree here because this already indicates 90 degrees. But anyways, perpendicular lines are where two lines intersect so that it's an exact 90 degree where they meet. Think of like a plus sign, right? That's where two lines crosses each other at 90 degrees exactly. So we can actually take a look at the slopes first, right? So let's take those three lines here. So let's plot those lines out. So GH is at negative 4, 2. And that's point G. H is at 2, 2, negative 1. Next line JK, negative 1, 7. K is 7, 3. And lastly, M, negative 4, 5. N is 5, 1. Okay, let's draw the lines. This is JK. MN. And GH. Oh, no. No. I just lined up perfectly with my ruler. Okay, there we go. Okay, we got three lines here. Again, they go infinitely. Okay, and we kind of notice something here, right? It's a very, very slight, it's very, very slight, but you can kind of see that this MN line right here, I can just move this, right? Alright, this MN line right here, if we can, it's kind of tilted ever so slightly, that if it keeps going, realistically, the two lines will cross. Right? Realistically, at one point, sorry, it's kind of hard to illustrate because the lines are very, very slightly off. And in hindsight, I probably should have made it more obvious. Right? But if we look at the slopes of those two lines, or the three lines here, right? Slopes of GH, good practice for the slopes here, right? GH is changing Y is negative 1 minus the 2 over, oops, 2 minus negative 4, which is just negative 3 over 6, which is negative 1 over 2. And then we look at line JK, 3 minus a 7, and then 7 minus negative 1. Okay, and last MN. Got 1 minus a 5. And then 5 minus negative 4. Negative 4 over 9, and then that's our slope. Okay, so we notice something here, right? GH and JK So GH and JK, those two lines have the exact same slope. And that tells us that those are parallel. Right, where's MN? Right, MN here has a slightly different slope. And as you can see here, this MN line is tilted ever so slightly that eventually, most likely will end up meeting the two lines. Right, so let me show a bigger line here. That's something like, so this is the GH line. Okay, I hope this is clear enough. All right, you can see here, GH line. Yeah, it's kind of hard to do an exact straight line here to illustrate it, but the point is, if two lines have the exact same slope, then that means they are parallel, right? Because if you think about it, right, if they're the same slope, right, at no point will they ever cross each other, right? Because they will go at the same angle, the same direction infinitely. Whereas if the slope is ever so slightly different, right, then they have a chance to cross each other. Right, so lines that are parallel have the exact same slopes. How about perpendicular? Okay, let's take AB here. Okay, 7 comma 6, B is 1 comma negative 2. Got A over here. Nope, that's 9, that's just kidding. 1 comma 2. Okay, CD. D. Okay, once again, get our ruler. Just like that. And we notice here that those two lines are perpendicular, right? They meet here at exactly 90 degrees. Right, so we're going to check out the slopes here. At line AB. Right, so it's this point minus this, negative 6 minus, or negative 2 minus 6. And then 1 minus 7. Which gets reduced to 4 over 3. Whereas line CD, minus 1, negative 1 minus 5. And then 8 minus 0. Reducing negative 3 over 4. Okay, so this is the slopes of two lines that are perpendicular. Right, so as a summary, right, parallel lines, the slopes are the same. But perpendicular lines, their slopes are what we call negative reciprocals. Alright, so remember when we were working with negative exponents, reciprocal is just a fraction flipped upside down. Alright, when two lines are perpendicular, it is when they are flipped upside down and with a negative sign. Right? So 4 over 3 is perpendicular to negative 3 over 4. Okay, let's do more slope practice. Alright, so let's see whether the following lines are perpendicular, parallel, or neither, without sketching them. Okay, let's find the slope of PQ. So it's 10 minus the 2. Oops. Negative 2 minus the negative 7. Eight over 5. RS, 1 minus negative 4. 5 minus negative 3. Alright, so right here, we notice here that they're reciprocals, but not negatives, right? If this is negative 5 over 8, then they're perpendicular, but they're not. They're also not the same, so this is neither. Okay, how about this one? -5 minus 7. 2 minus -2. It's -3. 6 minus 3. 7 minus -2. Right, and look at that. That is a negative reciprocal, right? Because this is just, if we flip that upside down, 1 over 3 to 3 over 1, which is just 3, put a negative sign in front of it, same slope as st. Right, so this tells us that those two lines are, it's a long word, perpendicular. Okay, so we can use this information to do some fun stuff now. Right, so now given point E and point F, find the slope of a line that is perpendicular to the line EF. Okay, so let's plot this out first. E is 2, 3. F is -4, -1. So this is the line we're looking at here. Right, that's line EF. Right, so what we need the slope of a line that is perpendicular to it. Okay, so let's find the slope of just the EF first. -1 minus 3. -4 minus 2. It's -4 over -6, which is 2 over 3. Alright, a slope of a line that's perpendicular to it is the 2 over 3 flipped upside down, reciprocal, with a negative. So it's -3 over 2. Okay, so now let's find a coordinate of a point G so that the line EG is perpendicular to EF. Right, so what this is saying that is, now we're gonna make a point G, so let's say a point G here, where if we connect the EG line, right, this line will be perpendicular. Right, so it'll be somewhere maybe like here, perhaps, right, where this EG line will be perpendicular. But we don't actually have to guess. We have the slope already, right? The slope of this line is -3 over 2. So now what we can do is go to point E and then use the slope, right? From E here, slope of -3 over 2 gets us a point here, right? Point G right there. And we know for sure that this line right here, oops, we know for sure that this line right here has to be perpendicular. Right, this line has to be perpendicular, right? Because, well, of course it looks perpendicular here, right? But we don't know for sure. But we know for sure because from E to G, we have the slope of -3 over 2, which is perpendicular to the line of EF, which is 2 over 3. So this point G here is at 4, 0. Right, we can always double check the slope, right? This new line EG, the slope of that is y, which is y of G, which is 0, minus the y of E, which is 3, over the x of the G, which is 4, minus the x of the E, which is 2, -3 over 2. Oh, right, so that checks out. Okay, last one. Is this a rectangle? Right, so what does that even mean, right? Remember, what's a rectangle? Right, in a rectangle, all sides or corners of a rectangle must be 90 degrees for it to be a rectangle. Right? A parallelogram is a shape. Will this work? Let's see. Oh, this works. Right. A parallelogram is a shape where two lines here and those lines here are parallel. Right? Of course, rectangle is a parallelogram too, right? We got two sets of parallel lines here. But most importantly, in a rectangle specifically, the parallel lines have to be perpendicular to each. Oh, sorry. In a rectangle, all the lines that form a corner must be 90 degrees. So we're essentially just checking, are all the corners here in this rectangle 90 degrees? And how do we check? We find the slopes, of course. Right, let's find the coordinates first. Right, coordinate of E is at negative 1, 3. Coordinate of H is 2, 2. F is negative 3, 2. G is 0, negative 3. Okay, so those are the 4 points. And now, if we find the slope of each of those separate lines, then we compare them to see if they're perpendicular. Then we can tell if that's rectangle or not. Okay, so let's check EH first. Y minus Y. This minus that. Okay, that's the negative 1/3. Line EF. This minus this. X minus dx. Okay, HG. This minus that. 0 minus the 2. And FG. Got negative 2 minus negative 3. Negative 3 minus 0. Oh, hold up. Right, so that gets us 1 over negative 3. Okay, there we go. Right, so here are the slopes. And as you can see here, none of those lines are perpendicular. Right? We can see the line EH and the line HG here, right? HG is 5/2, whereas EH is negative 1/3. Which means that those two lines are not perpendicular, which means that this is not a rectangle, right? Okay, the coordinates of a rectangle must be 90 degrees. But we know for sure though, right? EF and HG have the same slope, which means that those two lines must be parallel to each other. And EH and FG, right? Those two will also be parallel to each other because they have the same slope. If they don't, then this is not a parallelogram. That's just a fraud. Right? But unfortunately, none of the lines are perpendicular. So it's not a rectangle. Right? So that's it, pretty much it for today's lesson. Right? So all we need to really know is that the slopes of parallel lines are always the same. Slopes of perpendicular lines are always the negative reciprocal. So negative of the flip over of the fraction. But that's pretty much it. So, with that being said, good luck practicing.